Section 23 of Science History of the Universe, Volume 2. This is the LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. The Science History of the Universe, Volume 2, edited by Francis Rolt-Wheeler. Geology, Chapter 12. Physiography, Part 2. Coastlines are also of great physiographic importance. There is no greater mistake than to suppose the sea-coast to be merely a line whereat the sea now washes. Yet it would be easy to find many people who would define the sea-coast as being that stretch of land between high water and low water mark, with perhaps the addition of the former beach, in some cases, to the point of the beginning of land vegetation. Yet the coast line, truly speaking, may extend a long distance under the sea, and in a similar wise a wide range of marine beach formation may exist on land, even miles away from the sea. Regular coasts, says A. Penck, continue for great distances without notable indentations and, for the most part, in gentle curves, convex toward the land, which are connected by curved lines or meet at obtuse angles. The flatter the coast, the more perfectly is this type developed, and the coast line runs for many kilometers in the same curve. With a steep slope the course is regular only in general. In detail it seems as though drawn by a trembling hand, with numerous little prominences which project but a few hundred meters beyond the general coast line, and separated from one another by shallow, curved indentations. The most conspicuous example of the irregular coast unquestionably is the fjord, seen in Norway and Scotland. They are irregular to a wonderful degree, possessing only this in common, that they are produced by the depression and submergence of the land surfaces, not by the throwing up of the high bluff, cliffs, and crags that remain. The fjords are long, narrow, frequently branched, and usually very deep. The ridges of land which separate adjoining fjords are frequently notched by low passes, which seaward become straits, connecting the fjords and cutting up the ridges into islands, which are always very numerous along coasts of this class. The famous Inside Passage from Puget Sound to Sitka, Alaska, is a network of deep waterways among countless islands. What are termed Rias coasts have frequently been regarded as fjord coasts, but the bays here are shorter, more funnel-shaped, and not nearly so deep as fjords. Moreover, they are not of glacial origin, and hence are more widely distributed. Calais coasts are marked by numerous short, semicircular, and rather shallow bays, separated by narrow peninsulas, and owe their irregularities not to wave erosion, but to the submergence of land valleys. Those of the typical kind are due to the depression of mountain slopes, furrowed by numerous short ravines. Faults are probably the cause of deep, lobate coasts, such as are to be found in Greece and in Haiti and Japan. There the bays are not so much irregularities in the coast line as deep gulfs, which have taken into themselves hundreds of square miles of land surface, and where the interlocking gulfs are of the same order of magnitude. The popular use of the word mountain is another snare. For example, there are many so-called mountains which are nothing more than the tops of the original plain, the whole of the surrounding country having sunk. A well-known example of this is the Grand Canyon of the Colorado, where, although there are cliffs and buttes of immense height from their bases, yet a line from side to side of the great gorge will reveal that none are greatly higher than the surface of the plain from which the river cut itself down. Some so-called mountain peaks and ridges are merely the portions of dissected plateaus left standing, such as Lookout Mountain and Missionary Ridge in Tennessee and the Allegheny Front in Pennsylvania. A mountain range is made up of a series of more or less parallel ridges, all of which were formed within a single geosyncline or on its borders. The Appalachian Ridge, the Wasatch, the Coast Ridge are examples of typical mountain ranges. A mountain system is made up of a number of parallel or consecutive ranges formed in separate geosynclines, but of approximately similar dates of upheaval. The Appalachian system comprises the Appalachian Range, running from New York to Georgia, the Acadian Range in Nova Scotia and New Brunswick, and the Ouachita Range in Arkansas. Each of these ranges was formed in a different geosynclinal, but at the same geological date, and they are consecutive, having a common direction. A mountain chain comprises two or more systems in the same general region of elevation, but of different dates of origin. The Appalachian chain includes the Appalachian system, the Blue Ridge, the highlands of New Jersey and the Hudson, a system of different date, and the Taconic system of western New England, which was not formed at the same time as either of the others. A cordillera consists of several mountain chains in the same part of the continent. Thus the chains of the Rocky Mountains, Sierra Nevada, Coast Range, and their prolongations in Canada together make up the Rocky Mountain or Western Cordillera. From these definitions it will appear that the mountain range has a unity of structure and origin which fits it especially for study. If the history of the ranges be understood, the systems and chains will offer little additional difficulty. The manner in which mountain ranges have been formed must be deduced from a careful study of their structure, for no one has ever witnessed the process of that formation. Mountain building may be going on at the present time. Indeed, there is no reason to suppose that it is not. But so slowly is the work carried on that it withdraws itself entirely from observation. Nevertheless, the general course of events may be inferred with much confidence from the structure of the range. The first step in the formation of a mountain range must evidently be the accumulation of an immensely thick body of strata. This, of course, must have taken place chiefly under shoal water, as thick strata can be accumulated only in rather shallow water and parallel with shore lines. To accumulate thick strata in shoal water, the bottom must subside as the sediments are piled upon it, else the water would be filled up and the deposition cease. Such a sinking trough is a geosyncline, and in geosynclines filled with sediments is the cradle of the mountains. The second stage in the building of a range is the upheaval of the thick masses of strata into a series of folds. This can be produced only by lateral compression, a conclusion which is sustained not only by the mechanics of folding and faulting, but also by the less obvious structures, such as cleavage and fissility, metamorphism, the microscopic crumplings and plications, and the crushing and flowage of the mineral particles. The compressing force does not raise anticlines with great cavities beneath them, for such arches could not well be self-supporting, but mashes together the whole mass of strata, raising them into folds and wrinkles, crowding the beds into a greatly reduced breadth, or, when they are not sufficiently loaded to be plastic, breaking and dislocating them in great thrusts. It is not necessary to suppose that a mountain range was thrown up by one steady movement. On the contrary, there is good reason to believe that repeated movements, separated, it may be, by long intervals of time, have been engaged in the work. There are certain mountain ranges which have a different structure and must have had a correspondingly different mode of origin. As already pointed out, the Great Basin, which lies between the Sierra Nevada and the Wasatch Mountains, are a number of parallel mountain ranges with a prevalent north and south trend, which are collectively called the Basin Ranges. These mountains are not folds of very thick strata, but tilted fault blocks, which have been made by normal faults, each upthrow side standing as a great escarpment, but with a tilted top that gradually slopes back to the foot of the next block, to which it stands as the downthrow side. The process of denudation have carved these tilted blocks into peaks and ridges of the ordinary kind. Every mountain range has been profoundly affected by the agencies of denudation, and their ridges and peaks, their cliffs and valleys, have been carved out of swelling folds and domes or angular tilted fault blocks. The general character of the structure of the American continent is extreme simplicity, says Geikie, as compared with that of the Old World. In part of the Rocky Mountain region, for example, while the Paleozoic formations lie uncomfortably upon Precambrian gneisses, there is, according to King, a regular conformable sequence from the lowest Paleozoic to the Jurassic rocks, though probably many local unconformabilities exist. During the enormous interval of time represented by these massive formations, what is now the present axis of the continent appears to have been exempt from any great orogenic paroxysm and to have remained hardly disturbed by more than a gentle and protracted subsidence. In the Great Depression or geosyncline thus produced, all the Paleozoic and a great part of the Mesozoic rocks were accumulated. At the close of the Jurassic period, the first great upheavals took place. Two lofty ranges of mountains, the Sierra Nevada, now with summits more than 14,000 feet high, and the Wasatch, 400 miles apart, were pushed up from the great subsiding area. These movements were formed by a prolonged subsidence, during which the Cretaceous sediments accumulated over the Rocky Mountain region to a depth of 9,000 feet or more. Then came another vast uplift, whereby the Cretaceous sediments were elevated into the crests of the mountains, and a parallel coast range was formed fronting the Pacific. Intense metamorphism of the Cretaceous rocks is stated to have taken place. The Rocky Mountains, with the elevated tableland from which they rise, now permanently raised above the sea, were gradually elevated to their present height. Vast lakes filled depressions among them, in which, and on the plains in front of the mountains, as in the tertiary basins of the Alps and the Gondwana series of the Himalaya, enormous masses of sediment accumulated. The slopes of the land were clothed with an abundant vegetation in which we may trace the ancestors of many of the living trees of North America. One of the most striking features in the later phases of this history was the outpouring of great floods of trichyte, basalt, and other lavas from many points and fissures over a vast space of the Rocky Mountains and the tracts lying to the west. In the Snake River region alone, the basalts have a depth of 700 to 1,000 feet over an area 300 miles in breadth. End of chapter 12.